So I'm HP Marshall. I'm faculty at Boise State, and for the last 3 years, I've been co-leading SnowEx with Carrie Vuyovich at NASA Goddard, as well as a great leadership team that I'll introduce to you in a minute. Again, for Hack Week, we wanted to make sure this wasn't just a whole bunch of presentations, so there's not going to be a lot of overview on sort of SnowEx, but I want to point you to the website. And if you go over to the left-hand side and down to the bottom under resources, there's a link to all of the news that's been published on SnowEx. It gives kind of a high-level overview of SnowEx, as well as recordings of our monthly meetings that a lot of great people from the community have volunteered and stepped up and given talks on their data sets, a lot of the PIs that have produced these data sets. So what I'm going to do is I'm just going to start with about a 4-minute video that just is kind of a real high level overview of why we're doing SnowEx. And then I'll show just like 5 slides, and then we'll jump into Megan's tutorial, which will be on the core data sets. So let me see if I can get this video to start. Can everyone hear the sound okay?
Yes.
So just during this little bit of an intro part, if you haven't had a chance to get into the field, definitely reach out to me. There's a number of opportunities. The Snow International Working Group for Remote Sensing has a snow school that I encourage you to check out as well. And Carrie will be speaking in a moment on this video about SnowEx in general.
The SnowEx project is really a multi-year campaign to test different instruments and techniques for observing snow characteristics in different regions and different snow types. So we collect measurements on the ground with different ground-based instruments and observing techniques. We use that to validate instruments on aircraft and in the air, and eventually hopefully get some instrument on a satellite.
One of the advantages of Grand Mesa is its elevation. We're at over 10,000 feet here, and so as you can see, the snow is not wet at all. And so we want to start by really proving the concept in dry snow. A lot of the remote sensing approaches are also challenged by complex topography, so really steep topography. And as you can see, where we're standing here, we're on the top of a mesa, which is relatively flat. This is the largest mesa in the world, and so it's a pretty unique spot to do this work.
Within the pits, we're looking at the vertical stratigraphy, so the layering of the snowpack and the different characteristics of those layers, temperature, density.
I'm operating the snow micro penetrometer, which is one instrument that they use in the pit crews to look at the hardness of the snow and to look at the microstructure.
The microstructure is a very, very important characteristic for these active passive microwave retrievals, so we wanted to get that in a lot of locations.
I've just done a radar survey in a particular way, and we use this type of sampling strategy. We're calling it a Heimstra spiral. It's a spiral pattern. I'm making 100 measurements per second as I drive the snowmobile, and that is a very similar measurement to what's happening on the aircraft.
SWISAR really stands for Snow Water Equivalent Synthetic Aperture Radar and Radiometer, and it's actually 2 instruments in one. It has an active radar and a passive radiometer. Basically, they both work on the microwave frequencies. And what they do is to penetrate the snowpack a little bit and give us the volume scattering information, then which we can relate to how much water is inside the snowpack.
Snow water equivalent is really the volume of water that's stored in the snowpack. For hydrologic applications, that's really the most important characteristic. We want to know how much is available to melt and where it's going to go, evaporate into our groundwater reservoirs, and how much is available. I've been just amazed at how much we've accomplished. It was really above and beyond what we expected.
Oh man, this week has been incredible. Like what we got to perform our science or just think about that part and not have to worry about the other parts, because people took such good care of us on the logistics team.
A second team will hit one of the TLS.
Snow is a really important part of our planet. It provides water, hydropower. It's a water source for agriculture and water supply.
When we have snow in our mountains, it's holding it and it's kind of like timing the melt in like a slow release versus just an onset of rain or a flood event.
As we build these records for longer time series, we would be able to tell how the snow accumulation is changing over a given area and how that might impact the agriculture in that area or how the people live in that area.
I'm really excited about the potential right now. I think there's a lot of excitement in the snow community. There's a lot of collaboration. I think we really are at a point where we can push the science forward and move towards a global snow product and a satellite mission, hopefully.
Okay, so now I'm just going to follow that just with a couple slides to set up what Megan's going to start talking about and just kind of the SnowEx sort of side of this in general. Let me see if I can make this big. Okay. So just a welcome from the leadership team. Myself and I mentioned Carrie Vuyovich have been co-leading this effort along with support, lots of support and huge amount of effort from Kelly Elder, Chris Heimstra, and Mike Durand. Wanted to just again thank the NASA Terrestrial Hydrology Program and Jared Enton in particular for support of this effort. And really, this has been such a big team effort. We've had over 100 participants in the field from 20 different organizations on the field side of things. And now we're moving into this next step. And so I wanted again to thank the eScience Institute, in particular, Anthony and Scott and Jane and David, and a big shout out to Joe Meyer, who's been doing a ton of effort on this as well. Scott and Joe in particular have just really been working very hard to get all these tutorials to work well. I wanted to thank Micah. He's going to be talking a little later about the SnowEx SQL database, which is a great resource for our community. And then in particular, all of the organizers and the tutorial developers, they put a lot of effort into these tutorials and they're sharing their work with you at a really core level. So again, repeating what Anthony said, reach out to them and give them a thanks if you can. And then again, NSIDC team and Megan Mason in particular. Megan's a former student at Boise State and working for NASA and ATA Aerospace, and has been the liaison between our data PIs and NSIDC as we get these data products published. So thanks all there. So some of you have seen these slides. It sounds like a number of people haven't. Again, I would point you to those resources on the SnowEx Hackweek website to check out some of the other materials, and we'll continue to add to that. But in general, SnowEx is a multi-year coordinated airborne and ground experiment to evaluate different remote sensing technologies. And we want to do that in a wide range of landscapes, with the goal of informing a future satellite mission. And these are some of the gaps that are currently present in prairie, tundra, mountain snow, maritime forest, and wet snow, as well as snow surface energetics. And if you're interested in some of those details, there's a link there that I'll add to that resources page, which is the SnowEx Science Plan. So what did we do over the last 2 years, which is going to be a lot of the data that you guys will be working with. So over 2020 and 2021, we had a coordinated airborne and field-based set of experiments in the Western US. And that was kind of divided into two groups. One is a time series experiment with UAVSAR. This is an L-band interferometric synthetic aperture radar. And we wanted to test that as one approach to monitoring snow in a wide range of climates and during both accumulation and melt. And we did that. The map in the upper left here is where we flew in 2020 and 2021. We did 13 sites in 2020 bi-weekly until the pandemic shut us down. And then in 2021, we reduced to 6 sites so that we could get a longer time series, and we flew weekly 10 separate times over a subset of these sites. And then we did a detailed experiment on Grand Mesa, which was mainly driven primarily on SWE retrieval from active and passive microwave, and also a focus on snow surface temperature observations from thermal IR. And that included a 5-day snow off campaign in November of 2019, and then a 19-day snow on campaign where we had about 50 people on the ground, and our sampling strategy is shown there as well. So just a little more detail on Grand Mesa. This is where most of the data exists and where most of the data has been published so far, because it was kind of our primary observing site. So 150 snow pits, a whole lot of snow depths. I think a total of 30,000 depth measurements were made. Folks had ground-based terrestrial laser scanners out there, passive microwave radiometers and radars. We were measuring snow microstructure and snow surface temperature, and then a host of airborne instruments. So we flew 5 different aircraft with 7 different instruments, active and passive microwave with SWISAR. A lot of these, you're gonna see tutorials on these. So there'll be a tutorial on SWISAR. There'll be a tutorial on using the thermal IR observations and one on the UAV SAR. The LiDAR is kind of our largest scale sort of calibration validation information, and then the hyperspectral imaging. And then we had some partners that were not funded by SnowEx, but also flew over this site to leverage all the field work that we were doing and continue to encourage this community effort. So that was the gamma sensor from NoRisk and the FMCW radar from University of Alabama. Just a couple more slides here. So I wanted to hit this here. Snow science is really a team sport, and in general, field campaigns are always group efforts because we typically don't go into the field by ourselves for safety reasons. So they can be, field teams can be as small as 2 people. But in general, the SnowEx campaigns are quite large group efforts because we're putting a lot of resources into the aircraft and field efforts. And so I'd like you to think about Hackweek as an opportunity to make the analysis time of the side of this kind of project a team effort as well. So provide credit where it's due. In particular, the tutorial leads and the eScience Institute folks have been putting a lot of effort into making this possible, the data observers. But I want you to also try to ignore the fear of getting scooped and really embrace this idea of sharing. We are currently in a very data-rich environment, and the sharing will really lead to new opportunities and rapid increases in knowledge. So we're going to be all jumping into the same sandbox to play together, and we want to all share the tools that we've been provided and the tools that we develop from those. So thank you to everyone here for dedicating a week to building this open science culture for SnowEx, and welcome to all of you to being now part of the SnowEx team if you weren't already. I wanted to hit just this one more time. If you haven't seen the Nature paper by Bernard and Cooperdock, 2018, I'd encourage you to read it. It does show us that in terms of diversity and equity in the geosciences, we have not made any increases. We've made a lot of increases in gender balance, but not in diversity over the last 40 years. So SnowEx really welcomes and strongly encourages participation for people of all backgrounds, races, religions, and gender. And I want you to think about how open science creates this environment of equity and access to data and software and really promotes inclusion. And I'm definitely interested in any ideas you have to improve in this area. I'd love to talk to you more about that. And with that, I'll just say thanks to all of the different groups and all of the people that have been involved so far, and hopefully we're bringing in a lot of new people now too. And I will turn it over to Megan.
Hi everyone, and I'm so glad we're here. I feel like I've been thinking all winter about Hackweek and what kind of fun it would be to do this in summer when all the snow has been melted. So welcome everyone. Yes, so my name is Megan. I am the SnowEx Data Management Liaison, which means I help prepare and facilitate the publishing of the SnowEx datasets. Myself, Carrie, Vuyovich, and HP Marshall prepared this tutorial to introduce you to SnowEx and the datasets available for this growing community. So right now we're on the website and I'm running through the rendered version of my first of 3 tutorial slides, notebooks. And so you're gonna get inundated with so much good information. This little bit is gonna repeat just a little bit, but I think it'll help give you a really good understanding of the larger mission of SnowEx. And then my other 2 notebooks kind of delve into how to access and kind of extract data that you might want, and will help you start thinking about the project pitches for later on this afternoon. So I want to start by telling you the objectives for this tutorial. I'm going to give you some background and help you distinguish the different components of the core data. I'm going to describe to you the sampling design and the naming convention so you can use that to your advantage, and provide some examples to extract and prep data. again, we might do that piece after a small break. So what is mission of SnowEx? Well, like HP said, we have a multi-year program going on. It's funded by the NASA Terrestrial Hydrology Program. It is participant driven, and we are looking to identify the gaps in remote sensing and snow science. We are focusing our campaigns from airborne efforts and from fieldwork. We are comparing all of these technologies, whether they're really mature or not, or they're still in very experimental stages. So here's the roadmap, which is sort of the plan for SnowEx over the next decade. You can look at that a little closer, but we are going to, oops, let me click here. Keep going down. So where has SnowEx been? Our campaigns have been focused on various snow climates in the Western United States. However, our partnerships and our expertise are spread across the whole US and our international. The map on the left here shows the sites where SnowEx has been on the ground and in the air, and where we have information and data. It may not all be published yet, but these are places that if you're interested in working with it, SnowEx has been there. The table on the right is sort of just a very simplified summary of SnowEx campaigns by year and then by campaign style. So we refer to a lot of our campaigns as either intensive observation periods or IOPs or a time series. So the IOPs are where several SnowEx participants gather in one area, and we have really coordinated efforts to do an intense observation over a short window. We did 3 of those so far. 2 happened in 2017, where we started at Grand Mesa, and we also did work at Senator Beck. We then did another intensive observation period at Grand Mesa in 2020. That year was a really big year because we also then had 13 time series sites. So a time series site is a site with local SnowEx participants going to their field site, taking measurements at a consistent interval. We were going weekly to try to overlap with the airborne campaigns going on at the different sites. So 13 different sites all have SnowEx data. We took a subset of those sites in 2021 to repeat measurements and get more data. We added a site. We added the Central Agricultural Research Center in Montana to represent our prairie snow. So this is kind of an overview of where SnowEx has been and some of these site names. So what are the core data sets and what make them, say, different from the other data sets? The core data sets are intended to be standardized manual ground observations that are, again, collected by participants. These observations are providing a legacy data set that our intention is to use them for calibration and validation efforts of our remote sensing instruments. So we've lumped them broadly into 3 categories. We have snow pits, we have depths, and we have interval boards. Nice pictures of everyone doing various activities. So what actually, in the snow community, we talk a lot about snow pits. What a snow pit is a vertical profile from the snow, from the surface of the snow all the way to the ground. And it's where we collect a lot of information that can aid to instrument and model development. So all the different parameters that we collect are listed here, and I have them listed again in a few other spots. Depth's a little bit simpler, less involved, but again, really helpful for us as we're calibrating instruments. Snow depths are always going to have a georeference location and have a snow depth associated with it. We just happen to have a lot of different instruments that can collect that data. And lastly, interval boards. We don't have any published data yet on interval boards, but you should include this in as you are thinking about future projects. Interval board data sets are meant to track the change in snow over time. So generally, again, that's always a weekly interval, and we're working on preparing those data sets. So one more small table to sort of describe this. Again, we have our 3 categories listed here with the different parameters that each of the core data sets contains, and then a list of the different instruments that we use. And over here, this is kind of helpful and like a nice little status check. For the data sets that are published and available at NSIDC, the links are here in blue. So for the snow pits from the Grand Mesa IOP, we have the 2017 and the 2020 ones ready with their link. Same with the depths that we have in preparation and very close are the time series snow pits. And the future publications coming out will then be the 2021 time series. And like I said, other time series depths and interval boards. You can get a really nice overview of this if you visit the NSIDC page. You can link to it right here, and you can see a very full table of what other data products are available outside of just the core measurements that are potentially more specific to a certain site or one of the time series sites, or it didn't cover all of Grand Mesa, et cetera. Those products are listed both in tables by year for 2017 and 2020, and at some point we will add a 2021 tab. So just to start off with the most rawest format, these are the data that are associated with the snow pit. So this is a pit sheet. This is the field record of the data that we collected. This is an example from the 2020 Grand Mesa campaign. You can see here we collect density measurements, liquid water content, and temperature measurements, all at 10-centimeter intervals. We also look at the stratigraphy of snow, and within that we look at the grain size, the grain type, the hand hardness, and the manual wetness. We also have a spot for observers to leave comments to describe a little bit more. If these codes are unfamiliar to you, you can reference them all right here. Again, because this is a legacy data set, it's not intended to cover the entire spectrum of everything that we have in snow, but we've classified them according to these grain types. So that's sort of what makes it consistent across taking these measurements over multiple years and in multiple places. This is the back of the data sheet where we record environmental and weather data. It is more qualitative, but it kind of really helps set the scene for what it was like. And you can use that information to kind of maybe help select pits that you want to use. For the time series snow pits, this is where we fill out interval board measurements and the plot perimeter or more depth measurements around the probe. So taking the raw data, this is sort of what the data product looks like. These are what the data format is. So each snow pit contains a data package, and inside that are the parameter CSVs. So we have density, temperature, stratigraphy, liquid water content, and site details. Each CSV is given a standard header and then the data listed below. Also, the pit packages come with an image of the pit so that you can sort of see what the pit conditions were like. We also have 4 cardinal directions and an upward facing photo. We include the raw book images front and back, and then a pit PDF. Lastly, the summary files for an entire campaign are the environment summary and the SWE summary files. So that contains all of the pits for one campaign in a single file right here. So one more thing that's going to help you use some of the specific to the 2020 Grand Mesa campaign is knowing a little bit more about the sampling design and the naming convention. Like I said, you might want to use that to your advantage when you're selecting data for calibration and validation efforts. The sampling design was selected based on two large things. We had 2017 ASO LiDAR data that we binned into shallow, intermediate, and deep snow depth classes. And we also binned worldview imagery into different tree classifications with no trees, sparse, and dense. Both of those 3x3 options were pumped over here, and we created a 9-member matrix. So I'm going to scroll a little bit down and then go back up. We get all of our snow pits that occurred on top at Grand Mesa, and listed here with like the white little buffer backgrounds are the pit numbers. So every pit number, the beginning it's going to give you a little bit of information. So anything that has a 1 through 3 was taken in an open treeless area. 4 through 6 was sparse. 7 through 9 is dense. Likewise, those bins were then categorized. The low members of the vegetation class bins, the 1, the 4, the 7, show that those are not necessarily shallow snow, but in 2017, that's where the shallow snow or snow that was under 90 centimeters was. Similarly, we have the medium and deep bin 2. So that, again, that first number in the snow pit ID is going to cue you into a little bit of information there. You may not need that at all. Maybe you want all the pits that were done because you want the whole package. That's great. If you want to maybe grab something in a treeless area to look at your airborne observations, maybe grab just the treeless ones. The other component is the shape that we have. So these boxes are the flight lines. We had the cross line come through here. We had the north line and then the south line. And those are all indicated by the corresponding letters C, N, and S inside that. The rest of the pit ID is just numerical, moving from left to right, low to high. A quick little recap about just SnowEx and the data sets that we have. Again, SnowEx is a participant-driven NASA-funded project to lay the groundwork for a future snow satellite mission. Pits, depths, and interval board data are consistent between the different SnowEx sites, and they're intended for any of your needs for calibration and validation. And the published data thus far, pits and depths from the Grand Mesa IOP are available at NSIDC, and the user guides are incredibly helpful. I will talk a little bit more about that. That has a lot of information that will answer a lot of your questions. But also really exciting, these data sets are integrated into the SnowEx SQL database. So with that, I just want to say thank you again so much to the leadership team for making this happen, the logistics staff, the data management personnel, and the field participants. If you are not on that list, but you're here now, I'm thanking you now because you're an end user and we're really excited to have you use it. Yeah, this data, like HP said, we're very data rich right now, and we're really excited to start to really use it and yeah, use it. So strong work, everyone. With that, I'll pause and we'll decide if we're going to go on to a break or if I should jump into notebook number 2.
Just an announcement that we are still working on getting the Jupyter Hub up and running. Scott Henderson and others are looking through what's happening on the server. We've been using this architecture for a number of years now as a way to provide this sort of centralized cloud computing environment, and never have quite come across an error like what we're seeing here. So we're confident we'll be able to get it sorted out. We've got lots of folks who know this system really well. But at the time being, we'll have to just wait another hour or two. And so we're just going to improvise and appreciate, again, your patience with this. What we're thinking of doing is sticking to our original schedule here and doing our project breakouts. We can do all that without being on the hub. And then putting together kind of an impromptu session for the Git and the GitHub, maybe in an office hour style kind of format, perhaps offered at different levels as well for people who may be seeing Git still for the first time, or some of the more advanced content that Joe is getting into. So we're going to make sure that we cover that. It's kind of the foundation of the work we're doing here. So rest assured, we'll get to that. We may have to just improvise on how we set that up. And so I'm going to hand it back to Megan to continue with the SnowEx introductory tutorial. That should take us for another 30 minutes, and then we'll have a 15-minute break after that, followed by our project pitching.
Great. Okay. Hi, everyone again. Let's see. Okay. Welcome back. Yes, I am again on the SnowEx website, and I'm on the tutorials, and I'm now on the second of day 1. I'm on the second of the SnowEx mission and core datasets tutorial. So like I said, welcome everyone. We are about to dive in just a little bit deeper. The goal of the next 2 notebooks are really just to show you the tools to access data and give you code snippets to really extract and prep the data and really just generate some ideas flowing before you start pitching projects. This isn't intended to be like, you absolutely have to know how to do this solo. This is really like, you'll be given the tools to do this and we can work through the how-tos sort of together. One other thing I'll just say before we go a little deeper is I know that this is just so much information and we're all, you know, in our own workspaces and not together, but this has been like so far for me, like a 3.5-year journey since the first day I ever opened a terminal window. That was day one of grad school. So yeah, it might feel like a lot of new stuff, but I think just being in the mindset that it's really cool to be in the environment to learn new things. So again, grab what you can. Yeah, that's my little pitch. So we are diving in deeper. This is my notebook right here. At the top, I'm doing some imports. I'm just going to do some standard Python imports. I'm going to do some plotting imports. And then this is a little bit of a unique import down here, but this is our shared resources bucket for Hackweek. So we are I'm going to show you 2 big examples here of working with the depth data and the snow pit data. And you're going to learn a little bit more about the package contents of those data packages. So we're going to start with the simpler data set, the Snowdep data. In this tutorial, we're going to focus on the NSIDC side of things, so the snow and ice data center. And then on notebook number 3, we'll talk more about the database. So we're in depth, and from the NSIDC landing page here, you can check out the landing page, which there's an image of it here. And you can also download the user's guide. This user's guide has a lot of information about this data set and about the Grand Mesa campaign. So from this interface, you will have all these tabs. Right here, you can select user's guide or the download data. That'll kind of walk you through a lot of those. So I'm going to show you 2 methods of how to download and access data if you're grabbing it from NSIDC. The first one is to programmatically download Snowdep data from NSIDC. From their downloads tab here, I have the .py script that they provide. I've modified it to add the data into a folder that I want it to go into my Jupyter Hub. So when I run that, it queries for the SD, the Snowdep data, and it comes back with the file that we want. So I ask it to go into data and depths, and I'm right now looking for all of the CSVs, and it has this single 1 CSV file. And that's why I picked this one to start with. All of the snow depths from Grand Mesa over the 3-week period are contained in this file, and there are over 36,000 depths. It's possible that there is some introductory work, and if you weren't able to configure your programmatic access, those 2 steps would fail for you. So you can ask me and I can walk you through how to configure that programmatic access. But for right now, a good way that everyone can use the data too is to grab it from our shared resources server. And so this bit of code here is going to help link you to that. We're grabbing from the Amazon Web Service buckets that we have. We've labeled the bucket SnowEx data, and I'm asking for a file list. And so this file list contains 1 file that's the same file, and everyone is able to grab that. So I'm asking it here to open and read the file, and I'm going to create a data frame here. So a pandas data frame using the read CSV function. I am also going to ask it to parse the dates here so that I can return a datetime object. So when I run that, we say that the file is read and it's ready to use. I really like to check the data types when I first kind of open it up. That allows me to see the different columns here of data and then the data types that we have. And so like I said, datetime, because I parsed the dates, is now in a datetime format. I'm going to do a little work down below here to sort of prep the data. And I think that would be helpful before starting to plot things. These two columns up here were a little wordy for me, so I'm going to rename them, but you should take a second to read them. That are measurement tools, because again, with the depth data set, you have a lot of different tools that measure snow depth. So we have the MagnaProbe, the Mesa 2, and the pit rulers. So I'm going to just do a little bit of renaming of the columns here so it's a little bit easier later on. I'm also going to set up a little filter here to filter the dates from the first day of the campaign to the last day of the campaign. There were a few dates from our time series campaign that sort of ended up in this data set. So we're just selecting this range to just confirm that. And I'm asking it to filter by the start date and the end date. And then here I print out my data frame. And I also ask for the shape because I want to see that there are indeed over all of the rows here. There are over 36,000 rows. So that means we have this snow depth. There are over 36,000 snow depths that we can work with. They all have a pit ID and they all have geospatial information. So I'm going to use one of the Pandas tools, group by, to sort of start to sort the data. I'm going to sort it first by the different measurement tools that we have. And I'm going to take the mean snow depth of those tools and then print that out. So we have the Mesa 2 tablet, the MagnaProbe, and the pit ruler, and we can just see that we're able to calculate the mean snow depth. Now, again, these instruments were all around the Mesa in different places, so it might be an interesting project to see if indeed the Mesa 2 was really getting maybe deeper snow, or maybe just the areas that it went had maybe deeper snow. But anyways, we can use the group by to do that. So in this interactive piece, if we were on the hub, I would have you sort of try to use the group by tool to then select by the snow pit ID. So I'll tell you that all my examples, copy paste is going to be your friend. You would sort of be thinking about what you might want to modify up here, because up here we're grabbing by the measurement tool, what we would want to grab to do the snow pit ID. So we also know that we have all of our columns listed here, and we have measurement tool. So if I want to then sort by the pit ID, I would be interested in this column. So I would copy this, paste it right here, and I would change measurement tool to pit ID. It has to be written in the exact same way, and then it should run. And you would see that table. We would do that little exercise together. So the next little one is to find all the depths now associated with a certain measurement tool. If we've at this point forgotten the list of what measurements were around, I can do a search for the unique measurements and list them out. So again, my tools are the MagnaProbe, the Mesa 2 tablet, and the pit ruler. So now I can search in my data frame and I can locate from this column all the places that are equal to the pit ruler. Then I'm going to print that shape and print that data frame. So now we've decreased the size of the data frame and we're only working with 148 measurements. That matches up with how many pits we have. Yeah, so you can kind of see that, and our measurement tools are all now the pit rulers. Okay, so if we were to do this interactively, it would be your turn, and we would be searching now for the Mesa 2. So the big thing you would want to change there is we know that Mesa 2 is labeled this, and we would swap out the PR for the M2, and then you would find how many Mesa 2, and that's a tablet with a snow probe. That's that instrument. So then I just wanted everyone to be back on the same page, and we're back to using just the pit ruler. We're just gonna work with that a little bit smaller number and kind of show the different snow pits, because that's where the pit ruler was used. It was used inside the pits. So we're all back on that. And I'm just gonna show you two examples of plotting. We're gonna plot the locations and then on the Z-axis here, the depth. And so when I plot this image, the shape should look a little bit familiar. We have the cross line here, we have the north line, and we have the south line. So that's where we did all of our pit measurements, and those are all of the measurements from the pit, the snow depths. You might be noticing this point over here. That point was our base camp. That's the Grand Mesa Lodge. And that's where we also did a pit where we used all of the instruments that were part of the campaign to do a large comparison. So if you are interested in that pit, you are going to want to search for the pit ID called GLM Grand Mesa Lodge. You also might want to remove that if you just want to do the ones that were further out on the mesa. So just know that that's in there. The next one is just a histogram. We're looking again at the snow depths over Grand Mesa using the pit rulers. Okay, so now we are going to do a very similar workflow, but instead of using the snow depth data, I'm going to grab the snow pit data that's published at Nsidc. Again, this is the landing page. Here is a link to the user's guide, and this is what the landing page looks like with all of your nice tabs here to access the data. So again, to programmatically download it, I've used the .py script that Nsidc provides in the download tab. I've modified it to have it make me a data-pits folder. And then when I download it, this is around 6 gigs, and it downloads, all of the parameter files for each of those pits. So I actually queried just to do a single pit. So I'm sorry, I'm gonna scroll through these downloads because you would see that it downloaded, and it's nice and printed out for you. So just to show that we have those, and they were moved into this folder, I'm looking for just the ones that are named this. Again, remember we discussed the pit naming convention. We have the 5 on the north line, and it's the 19th one from left to right. And so here are all the files associated with that pit. We do have a lot of image files and the CSVs, kind of like we talked about earlier. I thought I queried just for CSVs, but that's later on. So then again, method 2, if we're going to access these right now, because they are all stored for everyone on the shared resources server. Again, that's in case you haven't finished setting up your programmatic access. So we're going to do something similar where we grab from the Amazon bucket that we have. We're going to make a file list, and this is where I sort for just the CSVs. So now I'm going to print those. And again, this is all for a snow pit on January 28th from this site, 1N6. And I just printed a list of these. These are 5 different parameters that we can work with. So if we don't really want to work with all the files at once, here's a few methods you might use to filter them. I'm just making strings here with variables, and then I'm going to use these variables, parameter, pit ID, and date. And I'm going to put them in my string here and use this feature .format. I'm happy to go over that, but basically I'm asking for, I'm putting in date, pit ID, and parameter into these curly brackets, and it's accessing it from there. I read in the CSV, and I just happen to know that there are 7 header lines. But again, you could print that in and kind of count those. So then when we have our data frame, we now have the height and the temperatures, kind of pretty nice and clean here. We know that the height of the snow is 102, and then every 10 centimeters down, we're taking a depth measurement. Sorry, taking a temperature measurement. And here's a quick example of how we would plot this data frame. Again, I'm plotting just temperature versus the height of the snow. And we can make a plot there. The last one on here is I am now going to switch which parameter I want. I still want it from the same date and the same time, but I've asked the parameter to be density. So that's going to reopen this. We're going to have that same consistent 7 header line. And now I have my data frame D. Data frame D, we have the top of the measurement, the bottom of the measurement, because as those density measurements were taken, they're 10 centimeter intervals. And we have sample A, sample B, and a third one if it was necessary. In most cases, these are all NAMs. I am really interested in computing an average density and adding a column to my table. So I'm going to name that average density and I'm going to put in my 3 columns. We do need, and I'm going to take the average across row based, and then I'm actually going to put this into to skip the nans. And so down here, when I print that again, I've now computed the average density for columns A, B, and C. The last one is now a function that's going to plot this in, I think, kind of a nice visual way. We can cover more of what's happening in here, but basically there's two major parts going on, and we're plotting the densities based on these 10 centimeter intervals. So we know that the measurement started at 102 and went down to 109. That was that sample pulled out, measured, and the density being, around 140 kilograms per meter cubed. And so the density is increasing as we go further down the pit. The red line here is showing the spread from sample A to sample B. Okay, with that, I will jump over to the third notebook. Okay, so now we are working with the same 2 data sets, but we are accessing them from querying our SnowEx SQL database. I want to say that this is just an absolute first taste of the database. We can go over each single line of code. There's going to be another tutorial on really getting more involved with the database here. But again, hopefully we are kind of learning what's possible, and again, it's a very small sample of what is possible for projects later on. So I have a few standard imports here, and then I'm importing the database. The database is going to come at its most simplest form with importing the database. And then these 4 tables are kind of important. The database is built upon 4 tables that are separated by point data, layer data, image data, and site data. Point data is something that is georeferenced with a single value. Layer data is georeferenced with multiple values. Image data are our rasters, generally always our airborne stuff. And then site data is more specific to the pits and all of that qualitative information that comes on the pit sheet. The last import that comes with this is the ability to, when you do the query, to then make a GeoPandas data frame. So this is going to be a pretty standard piece of code that you're going to need when you are loading the database. And these are 2 important keywords here. We get the engine and the session when we are getting and loading the database. So the snowpit data, because again, snowpits are kind of involved and cover a lot of different types of measurements, they're all contained in the database in three of the different data tables. So again, the point data are going to be the pit ruler depths and SWE values from that summary SWE file. Layer data is going to be things like density, because again, there's 1 point and there's multiple measurements moving down. So density, temperature, stratigraphy, etc. And then site data is going to be more of our site IDs, air temperature, et cetera, et cetera. So in this first example, I'm going to walk through 2 examples. Again, I know this is a lot. We're not going to see every piece of code here, but I want you to know what you can sort of do to query. This first example has four little parts, 4 examples within it. I think it's possible that a lot of folks will want to find pits that overlap with, say, an airborne sensor. So that means if we want to work with the airborne sensor data, we are interested in the image data here. But first, we also probably really want to know which airborne sensors are inside the database right now. So we are querying a session, and I am generating a list, and I'm printing that list, and the airborne sensors that we have right now being USGS, that's the DEM that we have inside the database, and then the UAV SAR and ASO LiDAR. So you might know that those exist, but this is kind of nice to know that this string, because we're going to use these strings to further our queries. So in the first example, say you are unsure of the flight date, but you know exactly which sensor that you are very interested in overlapping with. You're going to take that string, that sensor name, and we're going to query our image data we're going to filter by our sensor, and we're going to get the unique values and then execute the query. Because again, I'm looking for a list of dates that this sensor flew. I'm doing a little work down here to clean up the dates, mostly so I can print them for everyone to read them, and then kind of removing tuples and stuff like that. So that's sort of part one. And then the second part is now we have found our sensor of interest and the date. We're now going to query our site data table. And inside that, we are looking for all the dates that overlap. I am turning that query into a data frame right here, and I'm printing the top, and we'll go over this more, but we're then going to close the session. So right now, the UAV SAR team flew on 2 dates, January 31st and February 12th. And these are the point data that overlap with that. So we've already kind of taken this whole database and shoop, zoomed into some dates and sensors that we're interested in. Okay, second part, you want to select the exact flight date that matches. So remember, we returned 2 dates here, but say, okay, make the example a little smaller. Let's just grab it from this date. So we're picking the first item in that list right here. I'm again running essentially the exact same query, and I'm turning it into the data frame. I named this one data frame exact. Let's see, and then I'm printing how many pits overlap. So there are 17 snow pits that overlap with the UAV SAR flight date of the 31st of January, and printing them down here. Okay, so say you have 17 pits here. Well, you're kind of hoping to use a little bit more data. You've checked the snow tell towers, you know that stuff didn't change too much. Let's maybe think of a bigger range that we want. So if we would like a little bit of a range of dates, say plus or minus 1 date from the flight date, we can use this piece of code. Similar things, I'm querying, I'm asking again for site data. I am turning it into a data frame, doing a little cleanup, and now I have 47 pits that overlap on these dates. So minus 1 day, the exact date, and plus 1 day. I printed just a sample so that it spits out, it's random here, but we have a flight date we have overlapping snow pit data with each date. Okay, the last example looks a little longer, but again, it's a lot of copying and pasting and a lot of working with either point data, layer data, or image data. So if you have a known date, say someone says, we want all of the data in the database that happened on the very last day of the campaign, February 12th, how do we select that? So right now I'm printing you a list basically of the instruments, and then we have this filter, the type is sort of like the parameter that is associated with each of those measurements. So I'm grabbing all of the pit data, both the instruments. So I'm not actually grabbing the data right now, but I'm grabbing the instruments that are available and the parameter type. And then again, this is a little bit of work to clean up the dates and print some things out. I'm doing the same exact thing down here with instruments and type for layer and instrument and type for images. So here, this is printed out for you. The point data that are available on this date are these 3 things. We have the camera trap. There's a whole awesome tutorial on this one. We're going to have the magna probe and the pit ruler, and those are all associated with depth. Layer data, there's a lot going on with layer data. You guys will get more familiar, but we have the different instruments. We have some SSA instruments. We have some listed by serial number. We have the Snow Micro Pen. There's one that's not listed here, but it's the manual measurements that were taken. The instrument is labeled as none, so it doesn't show up, but the parameters involved are going to be density, force for the Snow Micro Pen, grain size, hand hardness, etc. Image data that shows up, we have UAV SAR and L-band data that both happened on this date. And then these are the data types that are associated with the image data. So just some examples on how to query and know what is available. Okay, we are almost done, everyone. Take a big breath. The next example is going to help us classify pit data based on the vegetation and depth matrix that we talked about in the first notebook. If you would like to distinguish by those, this is how you would do that. So again, remember, we have the vegetation coverage, and we have that split up into 3 categories: treeless, sparse, or dense. And again, that was based on 2010 worldview imagery. So this function is going to parse the vegetation into those classes. And all we need really is that site ID, because remember that first number in it gave us that information. So I built a dictionary here where we have treeless and it's equal to those 3 values, sparse, those 3, etc. I am grabbing the first number, that's the first instance, 0. Again, Python 0 being the first one. The first value in the site ID. And then for that value, I'm assigning the key that comes with it. And that key is the beginning of the words that are listed here in our dictionary. And then I return that. I've built another function that is nearly an exact replica, but it's splitting it into the shallow, medium, and deep classes. Again, those shallow numbers are the low ends of the vegetation bins, the 1, the 4, the 7. And this follows the same pattern here all the way up to deep. I will say that remember, these were classified based on the 2017 ASO Snowdep data. So if the patterns are not persistent at Grand Mesa, then these bins don't necessarily mean anything, but we do have a lot of data on how consistent patterns are. So anyways, that's a wide open field for someone to look into. But again, we assign these, a lot of it was based on the design plan and knowing like how long it might take, expect to dig a pit, etc. When we were out in the field. So again, these bins were assigned based on ASO data from 2017. It does this, the function does the same thing here. So we're going to use the function right here. This whole set runs through loading the database. Again, the keywords engine and session are grabbing it. We are querying for the layer data type. And in this query, I am asking for just density. I just want to work with the density parameter. I'm turning that again into a GeoPandas data frame. And right here is where we run those 2 functions. So in here, I'm going to add the vegetation class column and the depth class column. And right here, I'm using my function, the parse veg class, for every item in the list of site IDs. Similarly for depth class. This data frame spits out a pretty large one. So I've actually just selected sort of a list of the names that I kind of want to keep and hold on to. I've just done that here, and then I printed us out a sample. So we have our site IDs. These are all the different pit locations. And we have now added a veg class, and we've split them based on vegetation class. And oh, well, this one's funny. The sample happened to grab 5 that were from medium. That's okay. That's how that works. But it did correctly bin them into the shallow and deep too. Kind of fun. It runs different every. So 2 more quick things to show you are, then I use the group by function because I just kind of want to confirm or know, say if I'm interested maybe in doing an airborne sensor and I'm not too sure about it and I would really like to do it in maybe a treeless area, you're gonna, by separating out and grouping by and counting, you can know that you'll be working with 60 different snow pits. That's what that tells you, or how many bin into that. So again, the highest bin classes we had for medium was the largest amount there. Lastly, just again, remembering that you have a data frame, that's what you've queried, and we can start to make plots right from that. So if I'm looking, I queried for density data, I'm just looking at a box plot here where I've split things by dense, sparse, and treeless based on our columns that we created and plotting that. So not too much difference, but we know we can see a bigger spread going on where there's dense tree canopy. Similarly here in the potentially slightly deeper zones, we have a wider spread and slightly higher densities. So just showing you the tools that you have to access. Micah will talk more about this, but one way, if you get stuck on a query, this can kind of reset the query. You might use that as you're kind of coding a lot, and then we're always going to close our sessions. I believe this should be higher up in most cases, but I just wanted to put these tools down here for you. So with that, I'm going to call that good. And again, that was just your first taste of it. We'll have all week to practice.